Okay, question 2. This is a classic quadratics question. So for your quadratics, you should know, I'll just put this on the side, that for something like this, your b squared minus 4ac is less than 0. There's no real roots for that, is there? For something like this, I'll do it like that, or this, where you've got one root, then b squared minus 4ac is equal to 0. We don't say one root, we say we've got two equal roots. So for this one, there's no real roots. For this one, there's two equal and real roots. And for this one, I'll just do it. Doesn't matter if it's up or down. The point is there's two roots there. So b squared minus 4ac is greater than 0 because you've got two real and distinct roots. They're different, aren't they? Okay, so that's what you should be thinking when you do this one. So where has that equation got equal roots? Well, first thing I'd be saying is that b squared minus 4ac is equal to 0 for equal roots. Don't be confused by this equals 0. That's got nothing to do with the equal roots. That's just the way you have to lay your equation out in order for you to use the discriminant or the quadratic formula. So you have to have everything over to one side. Okay. So for this one, my b is k take away 5. So that's squared. And then make sure you get a bracket around this. A lot of people can make a mistake with that. So it's 4 times 1 times 1 again equals 0. Okay, so my A was the 1, yeah, that was B, and then C was the 1 there as well. If I had 1 plus K, then 1 plus K would be the C value. It's anything, that's left over. So multiply your bracket out, it is not K squared plus 25, no, remember it's 10K plus 25. I would have used, what I've done in my head is I've used this little table. Okay, so you can do the little table if you want, that's fine. And I'm going to take away 4 equals 0. Group all your like terms. So k squared minus 10k, what's that, plus 21 is 0. And look, sometimes it just pops out, you can see what it is. Other times it's a bit trickier. So I'll imagine it's a bit trickier, and you'd say, right, 1 times 21, 2 times nothing, 3 times 7. There we go, 3 and 7. So just write your factors down if you're struggling. Sometimes they are a wee bit trickier to spot than other times. Maybe I'll just rub that out just now, actually. Yep. So equals 0. So I've got 7 and 3, and they're obviously going to be negatives because two negatives multiply to your positive, and they add to negative 10. So that means that k is equal to 3, and k is equal to 7. That's the values that give me equal roots. So 3 marks for that one. There's usually, the way they make it harder is by saying not equal roots, but no real roots or distinct roots. And the only way you would do that differently is to start off by saying, okay, well, it's when is this greater than 0? So you would get to this point and you would say, well, when is this function, greater than or less than 0? But then you still do this same thing. You still work out the roots of this equation. Okay. So actually, if I draw this out, what I've got is 3 and 7 on here. That's my roots. Now, anything above this, okay, so these values here, okay, if I said then that k was less than 3, or k was greater than 3, greater than 7, that means that I've got b squared minus 4ac greater than 0. So that would give me real roots, two real and distinct roots. I looked at the value here, where k is equal to 3, and k is equal to 7, which is when b squared minus 4ac is equal to 0, which is your two equal and real roots. And then down here at the bottom, that's when k is less than 7, but is greater than 3, and that would be when b squared minus 4ac is less than 0. Yeah, so all the numbers down, just say here, all of these values, that's obviously less than 0, because it's, there's your 0 in the middle, and everything up here, that's greater than 0, isn't it? So when you do this, that's the easiest version. This is how you'd finish it off if it was asking for the real roots or has no roots. But you still have to do this bit where you put it equal to 0 to work out the roots. And actually, I'm just going to put that as a heading here. I'm just going to say roots along here, because no matter what, you're still working at the roots and then you're sketching. It just so happens that here, that was the answer. Okay, so most of the time, you'll have to sketch it and say what's happening with your b squared. Okay, so yeah, nice little question, comes up a lot. Don't be scared of the sketch at the end, and just make sure you get your terms right. Okay, so up here, for example, this is the variable. This is the one that changes in here. That might have been greater than, less than, or equal to, but then down here, you're always going to have equals because you're working out the roots to sketch it. Okay, and then you would make your final statement. Right. So that's a slightly easier one. Yeah. Hope that's helpful.